Now let's just move on further towards the second criterion for the similarity of the triangle, which is called as side criterion. So let's just see the theorem for the side criterion. We have, if in two triangles the sides of one angle are proportional to the sides of the another triangle, then their corresponding angles are equal and hence the two triangles are similar. So we just wanted to prove that if the sides of the triangle are proportional to each other, then their corresponding angles are equal. This is the thing that we wanted to prove, and hence at the end we have to prove that the two triangles are similar to each other. So let's just start the whole proof of the theorem by just taking the two triangles. So let us suppose if I am taking the two triangles as nothing but ABC. Let us suppose if I am calling it as nothing but ABC, and further I am taking a bigger triangle than ABC, which is nothing but DEF. So let us suppose if I am taking it as D, this is my E, this is my F. So let us just write the given statement. We have the two triangles. Given is two triangles, triangle ABC and triangle DEF, such that AB by DE is equal to AC by DF, which is equal to BC by EF. It is already given to us. So let us suppose if I am taking it as the equation number 1, it is given to us that their corresponding sides ratio are equal to each other. As you can see over here in the condition, it is given to us. Then we have to prove that their angles are equal. So let us suppose if I'll write it over here, we have to prove that the triangle ABC is similar to triangle DEF. We just wanted to prove this thing. So let us suppose if I'm starting with the construction, I'm taking the same construction like we did for the angle criterion. Draw, or we can say the cut. Draw DP is equal to AB. I'm just taking DP on DE in such a way that this DP is equal to AB, and similarly this DQ is equal to AC. Let us suppose if I am taking this Q and further join PQ, and I am now joining this PQ. So let us suppose this is my PQ now, and hence let's just start the proof of this particular theorem. So we are starting with the proof. As you can see, if we are starting with the proof, we know that AB by DE is equal to AC by DQ. This we know that these ratios are equal to each other. This AC by DF, sorry, this is not DQ, as AB by DE is equal to AC by DF. We know this fact. So this is my F, this is not Q, this is my F. So this is DF. DF means AB by DE is equal to AC by DF. We know this fact from this equation, that is the equation number 1, that they are equal to each other, So let us suppose if I am again rewriting this statement as nothing but in place of AB, I'm just writing DP by DE, DP by DE. We can write this thing as DE, and further we have this as AC. In place of AC, we can write DQ by DF. So as you can see, we can write the fact over here, since DP is equal to AB and DQ is equal to AC. So we can write this thing that DP by DE. So as you can see over here, DP by DE is equal to DQ by DF. So this is actually the converse of BPT. If we have the ratios or if we have the sides ratios are equal to each other, so this is all about the converse of BPT. So from this thing, we can say that by converse of BPT, by converse of BPT, we can say that if this thing occurs, it implies that PQ is actually parallel to EF. from this particular statement we can say that if the ratios are proportional to each other, then the sides are parallel, means PQ is parallel to EF by converse of BPT, we can say this thing. And hence if PQ is parallel to EF, then we can say that this angle is equal to this angle, and further this angle is equal to this angle. These angles are equal to each other. So let us suppose if I am writing it over here, it implies angle P is equal to angle E, and further angle Q is equal to angle F. Why? So because they are nothing but the corresponding angles. They are nothing but the corresponding angles. And the corresponding angles are definitely lying between the two parallel lines. So hence if the angles are equal to each other, as you can see, if the angles are equal to each other, then further what we can say that the triangle DPQ is similar to the triangle DEF by the angle similarity criterion. So we are already aware about this similarity criterion, that if the two angles of the two triangles are equal to each other, so hence by angle similarity criterion we can say that the two triangles are similar to each other. So hence if the two triangles are similar to each other, then what we can say that their corresponding sides ratio are also equal to each other. It implies that we can write it over here that DP by DE is equal to PQ by EF. We can write this thing by the criterion that if two triangles are similar, then their corresponding sides ratio, are same. So using this fact we can write this thing. So let us suppose if I'm putting it under a square, let us suppose if I'm putting it under a box and I'm just calling this as nothing but the equation number 2. Let us suppose if I'm taking this as my equation number 2, let us suppose if I'm taking it as 2, if I'm taking it as 3, so further we can say from 2 and 3, we can say that DP by DE, DP, this is my P, this is my D, this is DP by DE is equal to DQ by DF, which was is equal to PQ by EF, and further we can rewrite this particular statement as nothing but you can write this DP as nothing but AB. So AB by DE is actually coming out to be equal to this. DP can be written as AB because we know that DP and AB are equal to each other. So we can write this thing as is equal to DQ by DF. We have DQ. We can write in place of DQ as nothing but AC by DF, which is actually coming out to be equal to PQ by, we have this PQ, and further we have this nothing but EF. We have this PQ and we have this further EF. So we can write this as nothing but EF. So let us suppose if I am taking these two only, so we can write this as AB by DE is equal to PQ by EF, and further by the given condition, let us suppose if I'll write it over here, since we know that DP is equal to AB and DQ is equal to AC, and further we know that AB by DE is equal to AC by DF, which is equal to BC by EF, so we can write this also as nothing but BC by EF. From the equation number 1 we can write this thing, and again we can take these two things as PQ by EF is nothing but is equal to BC by EF. Let's cancel EF and EF altogether, so we will get PQ is equal to BC. We get PQ which is equal to BC, and this is the required thing that we wanted to prove. That is the equation number 4. So hence at the end what we get that AB is equal to the DP we have, and AB, as you can see over here, we have this AB and we have this AC. So further we can say that this AB, as you can see, this AB is nothing but is equal to this DP, which is a given condition. And further we have this BC. This BC is equal to, as you can see, BC is actually coming out to be is equal to PQ. And further we have this AC is equal to DQ, which is already a given condition to us. All the sides of the two triangles are actually coming equal to each other. As you can see, AB is nothing but is equal to DP by construction. BC is equal to PQ. This is the thing that we have proved in the equation number 4. And further we have this AC, which is equal to DQ. So if all the sides are actually coming equal to each other, so we can say that the two triangles, that is ABC, is congruent to the triangle DPQ by SSS congruency criterion. By SSS congruence criterion, we can say that the two triangles are congruent to each other. And if the two triangles are congruent to each other, so it implies that their angles are equal. Means angle A is equal to angle D, angle B is equal to angle P, and angle C is equal to the angle Q by CPCT. We can say this thing. And further we know that angle P is actually is equal to the angle E, and angle Q is actually is equal to the angle F. So it implies that angle A is equal to angle D, angle B is equal to angle E, and further it is angle C is equal to angle F. The reason being is angle P is equal to angle E and angle Q is equal to angle F. So hence at the end we have proved that all the angles of the two triangle are actually is equal to each other, which implies that the triangle ABC is similar to the triangle DEF. It is similar to the triangle DEF. We can say this by angle similarity criterion, that the two triangles are coming similar to each other. And this is the thing that we just wanted to prove. So hence proved the theorem that if we have any particular two triangles and the sides of one triangle are proportional to the sides of the another triangle, then the corresponding angles are equal. And we have proved this thing that the corresponding angles are coming equal to each other. And if the two triangles are equiangular, then definitely it is nothing but similar. So hence at the end, ABC is nothing but similar to the triangle DEF. So this is all about the theorem or the criteria, which is called as the side criterion. Now let's just move on further towards the another criterion, which is called as the side angle criterion. So let's just see the theorem related with it. So the theorem says that if one of the angle of a triangle is equal to one angle of other triangle and the sides including these angles are proportional, then the two triangles are similar to each other. So let's just start the theorem in the same way like we did for the other criterions. So let us suppose if I'm taking the two triangles over here as ABC, I'm just taking this one as a smaller ABC, and I'm taking the other triangle a little bigger than the ABC. So let us suppose if I'm taking this triangle as nothing but the DEF, and let us suppose if I'm starting with a given condition. The given is the triangle ABC and the triangle DEF such that angle A is equal to angle D. So why I'm writing angle A is equal to angle D? Because it is also already given to us in the question that if one of the angle of the triangle is equal to the one angle of the another triangle and the sides including these angles are proportional, so it means that if we are talking about the angle A and the angle D, so the sides that are including these angles is nothing but AB and DE and AC and DF. So it implies that AB by DE is equal to AC by DF, and always take this ratio as less than 1. So whenever we are just taking the ratio, we are always considering the ratio as less than 1. So always remember, whenever we are just taking, or I'm just writing these ratios in such a format, so these ratios are always less than 1. I'm considering this fact. So this is less than 1. This is already given to us. Now let's just see what we have to prove. We have to prove that the triangle ABC is actually similar to the triangle DEF. This is the thing that we wanted to prove. And now Now let's just further move on to what the construction. Again we are doing the same construction like we did before. Construction will says cut DE into DP, which is equal to AB, and DF into DQ, which is equal to AC. So I'm just taking the 2 points P and Q over here, and further I'm joining them and join PQ and join PQ. So let's just start the proof. So as you can see, for the proof I'm just starting with the two triangles. As you can see in the two triangles, let us suppose if I am taking the triangle ABC, and further we just want to prove that these two particular triangles are actually similar to each other. So as per the given condition, we have angle A as nothing but is equal to the angle D. So let us suppose if I am just starting with in the triangle ABC and triangle DPQ, we have angle A is equal to angle D, which is actually a given statement to us. Now again, if I'm talking about further, angle A is equal to angle D, and further we know that AB is equal to DP, and further we know AC is equal to DQ. This is actually by construction. So hence, as you can see, we have the angle and angle A and angle D, they are equal to each other. Their corresponding sides, that is AB is equal to DP and AC is equal to DP. So by SAS congruency criterion, we can say that ABC is actually congruent to the triangle DPQ by SAS congruency criterion. By SAS congruence criterion, we can say that these two particular triangles are congruent to each other, and hence if they are congruent to each other, it implies that their corresponding angles are equal to each other. So hence, if they are congruent to each other, so we can say that if they are actually congruent to each other, so it implies angle B is equal to angle P, further angle C is equal to the angle Q. Their angles are equal to each other, and hence further we can say this fact that their corresponding sides are also equal to each other. We can say BC is equal to DQ. So let us suppose if I'll write it over here, by CPCT, we can say this fact that their angles are actually coming equal to each other. So here again, if we can see, this angle is equal to the angle D, which is already given to us. Angle P is actually equal to the angle B, and further angle C is equal to the angle Q. So what we can conclude if we just wanted to prove that these two triangles are similar to each other? So again, we can write it as angle A is equal to angle D. It is already given to us. This is already a given statement. And now moving on further, we can write AB by DE is equal to AC by DF, which is already given to us. And hence again, we can write this particular statement as nothing but DP by DE, which is equal to DQ by DF. Since we know that by construction, that AB is equal to DP, and we know that AC is equal to DQ. So we are writing this particular fact over here. So as you can see, the part and the whole side ratios are coming equal to each other, which is nothing but the converse of BPT. So by the converse of BPT, if the ratio is actually coming equal to each other, it implies that PQ is actually parallel to EF, and if PQ is parallel to EF, it implies that the angle P is equal to the angle E, and further angle Q is equal to the angle F. Why so? Because they are nothing but the corresponding angles. Because if the two lines are parallel to each other, so this angle is equal to this angle is equal to this angle. So hence we can say that, let us suppose if I'm writing it over here as this. So these angles are already equal to each other, or we can say these angles are also equal to each other, but we further know this fact that angle B is equal to angle P and angle C is equal to angle Q. Means this angle is equal to this angle and this angle is equal to the angle Q. So as you can see over here, if angle B is equal to angle P is equal to angle E, so angle P is equal to angle E. And further, if this angle is equal to the angle Q and angle Q is equal to the angle F, so angle C is equal to angle F. So at the end, what we are getting at the end, it implies that angle B is equal to angle P, which is equal to the angle E. Further, angle C is equal to the angle Q, which is further is equal to angle F. So hence at the end, what we are getting, angle A is equal to angle D, angle B is equal to the angle E, and angle C is equal to the angle F. So it implies that if all the angles of a particular triangle or of two triangles are equal to each other, means the two triangles are equiangular, and hence if the two triangles are equiangular, it implies that the triangle ABC is similar to the triangle DEF, and this is what we wanted to prove that. So hence, by we can say that this is the thing that we wanted to prove, hence proved that the two triangles are similar to each other. So this is all about the side angle side criterion.